I do my PhD in studying APIs and perform some comprehensive analytics about them. And today I will give you some insights that were gotten from an analytics about API versioning. So versioning is a concept that is too much linked to the composition of software components. So when we have two software components and we need to compose them, we have to be careful about what versions of these two components we are going to compose, because the compatibility is not really ensured. Like, you're not going to be sure that the compatibility is covered, like between the components will be between all the versions of these two components. So, for example, if we look at some real-world examples, this is the MongoDB node model. We can see clearly that it has some kind of, it relies on some external dependencies. So as a user, you have to be careful to keep this, like the versions of these specific models. And as a developer, it's even more complex. This is like a visualization that includes the development dependencies. So imagine how hell of a problem would be to, if you want to upgrade a specific component. So NPM uses a very specific way to version the models. It relies on semantic versioning, which it uses specifically 3 digits. And in their website, they define a very clear rule about how to increment each digit when you want to upgrade, for example, a new version of your package. You have specific rules and you need to follow them in order to know how to release the next version of your package. However, even though we can see some very famous packages that are available and used by millions of users, they still misuse semantic versioning. And we have some angry people saying, for example, when underscore released the 1.7, they were saying that's not a 1.7, it should be a 2 release. And for NPM, for example, there weren't some studies about how these packages adhere to semantic versioning. However, for some repositories like Maven, there are some studies that tries to check how much people adhere to semantic versioning when they release their packages. So, for example, in 2017, the author found that breaking changes, which are supposed to be only in major upgrades, they found them spread over different upgrades of the packages. We can see that the percentages are almost similar. However, they could notice a slight increase in the adherence to semantic versioning principles over the years. And in 2022, other authors replicated the study, and they could find some better news. Some good news is the fact that now more than 80% of the repositories on Maven are actually adhering to semantic versioning principles. And in this kind of tools where it is possible to release your package, and then you can have some kind of nice tooling, such as the npm check updates, for example, available on npm, and you can just go and then with a command line, it can show you the different upgrades that you can, updates of your dependencies, and you can decide to upgrade or not. And of course, this will be relying on the fact that people were using semantic versioning correctly. So here's the question. Now we looked at specific kind of APIs, which are, you're not really responsible of deploying them yourself. You have a tool that manages the versioning for you somehow and can help you, for example, to pay attention to if you did upgrade or not the version when you released your new versions. So what about web APIs? We know that web APIs are not centrally deployed, so there is no such nice tooling that can help you. And how to actually version them. So if you just Google how to version a web API, there is really a lot of answers and talking about their own version, about how to version and defending their ways in a very strong way. So we're not gonna really be part of this drama and try to answer this question, how to version web APIs. There is a lot in the web already. And so we are going to flip our question, and instead of trying to answer it, we're going to see how developers actually version their APIs. So we went to GitHub and we fetched more than 7,000 APIs. And we only selected the ones that have more than 10 commits. We fetched their specifications written in OpenAPI. And our data set were containing specifications of APIs from 2015 to 2022. So here's an overview about how the data set looked like. If we look vertically at a column, this is an API. And if you look from the bottom to the top of a column, this is specifically the age of the API. The APIs are sorted by their first timestamp, and then the color is the date of the specific commit. So it can show us like how recent are the commits that we have in our data set. And one thing that we can notice is that the recent APIs, they have much more dense commits. Like there is much more going on if we compare the early commits of the last APIs. Maybe because a lot of people were adopting OpenAPI, not easy for them to reflect their changes and everything. So there was a lot of early commits. And also, if we look at the commits versus the version changes, we can clearly see that not every commit comes with a new version. So, and of course, so when you are updating, deploying your new version of the API, you don't want some angry user to come to you and tell you, hey, my API is not working anymore. Because if you deploy a new version, you don't keep the old one, of course, nothing's going to work, and then you have to do something about it. And for that, there is the all-in production pattern, which means that you have to keep the backward compatibility. And as I told you before, like for the other kinds of APIs, it's much more easy to handle this because you're not gonna pay the cost of this by yourself. There is a lot of tools that can enable you to host your multiple versions. In the case of web APIs, this is reduced to at least 2. Like we should have at least 2 available versions. You please keep the current one and the old one. So we're actually going to look at this and see if there is in our data set some multiple versions, some APIs providing coexistent versions in the same time. And we found like among 7,000 ones, we found a bit more than like 150, 175 APIs that were adopting the 2 in production version. The 2 in production pattern, and we found the majority exactly providing 2 versions, while some very few ones went too much further and provided more than 2 versions. So how is this coexistent versions pattern of coexistent versions of APIs is ensured is mainly by using the path-based version in practice. So in that case, I'm sure all of you have used some APIs where you see a V1, V2, or some version identifier at the beginning of the endpoints. So that's a path-based versioning where the version is a part of the endpoint, part of the path. And whenever you produce a new version, you attach again your endpoints to the same and version identifier. So for example, this is an example of an API which started with 1 endpoint, and this is the endpoint. It's a get endpoint, and even though you can notice that they added since the beginning a version identifier even with 1 endpoint, and then the API kept growing in new commits. They started upgrading the version, but you can notice that they're only upgrading the patches where they are really adding a lot of methods. So you can see also that the structure of the API is getting much more complex. And at some point, they stopped upgrading the patches and they upgrade the minor, and they added a new subset of endpoints attached to a new version identifier, too. So this was their way to version their API. But we can notice that even they started with a 1 endpoint, they attached it to a version identifier because they were seeing this upfront and they wanted to use this way of versioning. So you cannot at some point just go and inject a version and identifier to your endpoints, and you cannot do the opposite also. You cannot try to simplify your endpoints and make some people angry, come in to complain, and your goal was just to simplify. So when we looked to our data set, actually found cases that passed from, for example, not having any version to injecting a version in the path, or even some who at some point added the version and then they removed it for the sake of simplifying, and they made some clients angry. And another case of APIs were the ones who actually, they didn't use any path-based versioning, but this is a size of, you can see that the size of the API grows, and then they are, what you see there, the labels are the version of the API, and they version the API using just a metadata-based versioning. So they didn't include it. When you use the API, you actually don't know what version are you using, but you have to look in some documentation to know what's the current version. And some APIs will be a bit generous and will provide you an endpoint. For example, in that API, you can see that there is no version identifier in the endpoints, but they provided a specific endpoint that can notify you about the version, the current version you're using. And this is what we call dynamic versioning. So looking at our data set, we could see a high number of APIs, well, relatively high number of APIs that were using metadata-based versioning. And even though only 2% used at some points in their history in some commit a dynamic versioning, and we could see also some number of APIs, 30% used combined both metadata and path-based versioning, and only 1% used only path-based versioning. But this can be because the fact that we targeted APIs that are documented using OpenAPI. But even though, and this is like if we look, for example, to the APIs that at some point in their history included some versioning. So in their history, there is like 70% of the APIs that at some point in their history added some version information to their specification. And I was saying, like, we have only found 1% that only used path-based versioning, because we targeted the APIs that were described using OpenAPI. And the field of the version in an OpenAPI specification is actually required. So some developers even just wrote the field but kept it empty. So they didn't write any version in there. So there is another type of versioning which we didn't include in our study. It's called a header-based versioning. When you have a client who wants to talk to an API, but this API actually has multiple versions, and you want to talk to a specific one, but you have only one way to reach them, which is the /API. So from your side, like you want to, for example, target a specific API of these, and then from your side, what you're gonna do is that, like, you inject a version identifier to the headers, and then from the provider side, they have to provide some way, like some upfront proxy or something that will be able to route the request to the specific instance of the API that you want to target. So, and this is done using like the headers. And for example, if you are using curl, you can just do like this, and then you specify the value of the version identifier of the API you want to target. And these headers are usually, most of the people use custom headers, which is actually not really a straightforward approach, because we don't have only one. Every API and every provider use like their own one, which is not a user experience, like from our user experience side, not something that developers like. So since we didn't include this in our study, we're planning to include it, and also to look at different approaches that come with this way of versioning from the implementation side. So let's look at as an example, it's a very famous API. I'm sure many of you have already used this at least once to fetch some repositories from GitHub. And okay, I will let you just look at this for a while. GitHub API didn't use versioning at all. They didn't version their API. They didn't even bother. And if we look at, for example, I just give you an example. That's if I try to visualize their API in the way I showed you the other visualizations, it's very impossible to visualize it, just because they just kept growing. They attached everything and added everything to their API. and until the API became something not very easy to, even if you want to look at the documentation and look what specific endpoints you want to use, it's not something that is easy. And also there's the OpenAPI specification is too much long. It's almost 300,000 lines of description. Yeah, so that's GitHub API. So, and if we look at their OpenAPI description, they use some version identifiers actually there, but you can see that the version they're using there, it's not the version that is in the title. So it's clearly that it's not something very seriously done. And fortunately, a few months ago, they said, okay, we're going to use versioning. And it was in November of last year, like 5 months ago, 6 months ago. And now if you go to GitHub, they still have this notification. Now we are using versioning. The REST API is actually versioned. And they are telling you, like, if you want to upgrade, you have to go and read our change logs every time. And we are using a header-based versioning approach. And for example, now if you want to go and fetch something from GitHub, you have to attach to, again, they define their own header. And you have to attach the version identifier to the header to be able to fetch some things or use any endpoints. But this still works because now they only have one version. They didn't use versioning. So since they plan to use versioning, they went again to their API and they attached a new endpoint that will allow you to fetch all the available versions of the API. And yeah, now if you try it, it will return one date. And yeah, they use a date. So they are using a calendar, what is called a calendar-based versioning or a calendar versioning. They are not using semantic versioning, which is also funny because the person who wrote the semantic versioning specification is the co-founder of GitHub. And so since there are different formats of versioning, we wanted to look at all the formats that were used to version all the APIs that we have in our data set. We went to about 200,000 commits, of commits of the APIs that we have, and we extracted any version identifier we found in the version field in the OpenAPI specification. We could find 5,511 version identifier. But the version identifier could appear also in the endpoint. So we actually cleaned this a little bit, and then we used this data set to extract this set of version identifiers to extract the version identifiers from the endpoints. And then we found in the endpoints like about 400 distinct version identifier. But since in OpenAPI, this field is actually just a string, we couldn't know whether they're using semantic versioning, date, or what is it exactly. So yes, I forgot to highlight this. The version identifiers we found in the endpoints were a subset of the version identifiers we found in the metadata of the APIs. So we took these version identifiers, we built a parser, and we had to inject a set of regular expressions so that we feed it with a set of parsers in order to be able to classify and to classify our versions. And then we were growing our set of regular expressions until we had the least number of not classified version identifiers. And then we again used it for classifying the version identifiers we found in the paths. And then we could again classify most of them. And we had a very small subset of version identifiers which we couldn't classify. And all these regular expressions and the rules and everything, they are defined in a public GitHub repository. So at the end, we could find 55 different ways to express a version. 27 of them, they were to version stable releases of APIs, and 28 were to version pre-releases of APIs. And looking at the most common ways to version, where maybe you could have expected this, was the semantic versioning using the 3 digits. The majority of APIs used it. Then the semantic versioning using 2 digits. Then a V then a digit, then finally the one that GitHub was using, like a date with dashes. So we also went to these stable releases and pre-releases formats, and then we grouped them depending on how they look like or their type. Also, we classified these ones depending on what version, what actually pre-release are they referring to. So we found that semantic versioning was like used in a very stable way across APIs. More than about 5,000 APIs used semantic versioning during their whole history, or they used just a version that like refers to the major version of the API. And looking at the APIs that actually changed version during their history, they changed their format that they were using during the history. We could clearly see that there is some kind of migration towards semantic versioning in their history. So here we wanted to look at the usage of semantic versioning to version stable releases of APIs over the years. And we could see actually a kind of a stable, like the proportion of adopting semantic versioning to stable releases was kind of stable over the years. However, if we look at the usage of semantic versioning to version preview releases, we could clearly see a kind of drop of adoption over the years. And when we looked at it deeply, we've noticed that developers actually prefer to use some simpler formats like these ones, or like more specific to version pre-releases than using semantic versioning. This is an example of an API that used both metadata and path-based versioning, and you can see that the metadata versioning is much more detailed, and the path-based versioning is like they remove the second digits, but they are not really using semantic versioning. So what about the APIs that have multiple coexistent versions? What kind of formats do they use? So we could find that using just a major version number was the most common format to version these kind of APIs. And however, if you zoom to the other formats that we found used, we could find also a usage of combinations of different formats for different versions, for different coexistent versions. And to wrap up, how do developers version web APIs? We could find the usage of the two in production pattern, however, in very few APIs. We also found the APIs using the path-based versioning. However, we found about 500 APIs that were misusing it and were playing with it during the history of the APIs. And we could also find 70% of our data set was using metadata-based versioning, even if actually we targeted the open API, described APIs where the version is a mandatory field. And regarding the formats, we found that there is a variety of formats. We found 55 different formats used, where semantic versioning was the most stably adopted format. And we also found that semantic versioning was kind of dropped over the years when it comes to versioning pre-releases of APIs. And yeah, as a future work, we would like to not only look at how to version. Now we know how developers version the APIs. So we wanted to look at when do they actually do a specific upgrade of when do they do a specific upgrade of their version, and what are the types of changes that drive to every specific version upgrade. So for that, we plan to focus on the APIs that are using semantic versioning, since it was the majority of our data sets, and just look at the diffs of changes between every commits of the APIs, and then also look at the version upgrades, and then analyze what is happening there to know how APIs handle their developers handle their versioning. And yeah, these are my references. And if you want to look again at the slides, they're here. And thank you.